Hello students, my name is Deepak Singh. In today's video I will talk about SN1 reaction. SN1 reaction SN1 reaction is a type of SN reaction. What is SN reaction? So SN reaction is substitution nucleophilic reaction. Substitution nucleophilic reaction. Okay, so it is also called nucleophilic substitution reaction. So substitution nucleophilic reaction or nucleophilic substitution reaction is a two type, SN1 and SN2. Okay, so SN1 and SN2 mainly it is also type of SNI, SNNGP, but in your syllabus it is SN1 and SN2. So what is 1 and what is 2? So this 1 represents unimolecular reaction. Unimolecular reaction, and this 2 represents bimolecular reaction. Bimolecular reaction. So in this lecture I will specifically talk about SN1 reaction. So as I told, this is a substitution nucleophilic unimolecular reaction. Unimolecular reaction. Okay, so in SN1 reaction, major substrate is haloalkanes, and other also like if leaving group is tosyl group, oxytosyl group, and other. So in your syllabus here only substrate is alkyl halide. So this is type of RX. So X can be here chlorine, bromine and iodine. So alkyl halide RX will react with one nucleophile. As name suggests, substitution nucleophilic, that means one nucleophile will substitute others. So this is incoming nucleophile. So this nucleophile will attack on alkyl group and this will remove. Okay, so this is a two possibility. One possibility is first X will migrate and carbocation will form, and next step is attack of nucleophile. So this will attack on carbocation and then product will form. So this is first possibility, and second possibility is this will attack on this alkyl and then X will remove. So in SN1 first carbocation will form and then nucleophile will attack. If this will attack on alkyl and then this will go outside, then that type of called is SN2 reaction. So here we are talking about SN1 reaction. So this will not attack directly on the alkyl halide. First carbocation will form and then this will combine with R plus carbocation and that will form product. So here you can see this is a step 1 and this is a step 2. So SN1 reaction is two-step reaction and This is a slow step. Slow step. So in any reaction, slow step is the rate determining step. So this is our rate determining step. This is RDS, that is rate determining step. Rate determining step. So SN1 reaction is a two-step reaction. First step is formation of carbocation and second step is nucleophile will combine with carbocation and that will form product. So as you can see, carbocation formation is slow step, rate determining step, RDS. So here, from here we can say rate of reaction is directly proportional to formation of carbocation. Is directly proportional to formation of carbocation. So rate will depends on formation of carbocation. As carbocation formed fastly, then rate is also going to increase. So how we can determine formation of carbocation is fast or slow? So formation of carbocation So formation of carbocation is directly proportional to stability of carbocation. Stability of carbocation means if carbocation is stable, then that will form fastly. If carbocation is not stable, like if we will take an example, it is a 2 degree carbocation and it is a 3 degree carbocation, and let's suppose this is a 1 degree carbocation. Okay, so if we compare 1 degree, 2 degree and 3 degree, which will form fastly? So how we can determine? So we can determine on the basis of stability. 3 degree, 2 degree, 1 degree. If 3 degree is more stable, so this will form fast. If this is more stable, then this will form fast. So if we see on the basis of GOC, then we know 3 degree carbocation is more stable than 2 degree than 1 degree. So if this is the stability, order of stability. So if this is more stable, then this will form first. So if we compare rate of reaction, this will form first, so this will go fast. So rate of reaction, rate of SN1 reaction is also first 1 degree is less than 2 degree and 2 degree is less than 3 degree. So here all about is stability of carbocation. If stability of carbocation is higher, so SN1 reaction is higher. So here we can write a key point like rate of reaction or rate of SN1 reaction, more specifically SN1 reaction is directly proportional to stability of carbocation. Stability of carbocation. So any reaction, if we compare rate of SN1 reaction, then we will see stability of carbocation. Okay, so this is the rate, how we can determine rate. Other is in SN1 reaction, this is substrate, this is nucleophile. So here two other points is, first is what type of nucleophile we can take and what is the solvent we can take. So in SN1 reaction, this is a key point. If we will talk about solvent, what type of solvent we can take? So in SN1 reaction, we will take polar protic solvent. Polar protic solvent. Polar protic solvent. Like example is any alcohol or H2O or acetic acid type. So these are polar protic solvents, etc. What means by polar protic? So if mu, dipole moment, is not equal to 0, then that molecule is polar molecule. And what is mean by protic? So if any solvent can give proton H plus, then that solvent is protic. So these are polar and also these are protic solvent. So why we are taking polar protic solvent? So why we are taking polar protic solvent? Polar protic solvent. Okay. So in the reaction mechanism, I see carbocation formation is the rate determining step. So if any solvent can stable this carbocation, then rate of reaction is going to fast. So polar protic solvent stabilizes carbocations that will increase the rate of reaction. So polar protic solvent stabilizes the carbocation, and also polar protic solvent help to form carbocation. How? So if let's suppose alkyl halide like chloride, if chloride is not going to outside, then any polar protic solvent, like if you are taking H2O. So due to this polar bond, because chlorine is more electronegative than this carbon, so here delta negative, here delta positive, and oxygen is also here delta negative and here delta positive, because oxygen is more electronegative than hydrogen. So if chlorine is not going to outside, so this will interact with this and that will help to going outside. Although 1 degree will not go to or SN1 reaction, but if we are taking example, then we can take 2 degree also. So if 2 degree alkyl halide is there, then this will help to form here carbocation R CH, here positive R dash. So this will stabilize it. If here oxygen will stabilize it, because here delta negative, here delta positive. So oxygen will stabilize this carbocation and this delta positive will help to form carbocation. So these are the reasons why we are taking polar protic solvent. Okay. Now our third part of the reaction is nucleophile. What is the type of nucleophile we can take? So here nucleophile. So here nucleophile should be weak nucleophile and like neutral nucleophile. Why we are taking weak nucleophile or neutral nucleophile? Because neutral nucleophile is a weak nucleophile generally. So we are taking neutral or weak nucleophile. Why we are taking weak? Because in the reaction, as I said, if nucleophile is giving this reaction, then first carbocation will form R plus X minus, and then nucleophile will so here it can be neutral. So if this will neutral, then this will have lone pair. Okay, so this will attack on this and that will form product. Like X minus. Okay, so nucleophile should be weak. Why? Because in the rate of reaction, no role of nucleophile. This is the rate of reaction RDS step, slow step. So if this is a strong nucleophile, then this will not wait to form carbocation. This will, here nucleophile direct attack will alkyl halide. So that will give SN2 reaction. So we want to go SN1 type. So we should take weak nucleophile. What is the weak nucleophile type? Like example is NH3, H2O, or any alcohol. So these nucleophile have lone pairs and that will attack on the carbocation. Another, if we are go in the depth, so like this is the halogen and this is R, this is hydrogen and this is R dash, then this will form R dash, here R and carbocation and hydrogen. So here this is sp3 carbon center. I am talking about this, and here it is sp2, that is a planar. So this is like this R and this is like this R dash, and carbocation is in vacant p orbital. Okay, so now nucleophile can come from here or from here. So we can get two products, from upside, from downside. Nucleophile R dash and hydrogen, and also R dash hydrogen and this. So these are two products and they are enantiomers. And these are also called racemic mixture. So 50% this and 50% this, because both have equal probability from upside attack, from downside attack. So we will get racemic mixture product, racemic mixture product. So first is this, second one this, and both are enantiomers. Okay. So in next lecture I will talk about graph of the reaction, energy profile diagram, and today's lecture I will conclude on what is the type of product we will get. Thank you.